Today I'm going to be going over my midterm presentation. So the task of this project was to implement these two research papers, where the first one introduces an algorithm known as backwards energy, which is used for identifying seams with lowest energy in images, which you can then remove or expand upon. The second paper introduces an improved algorithm, which is otherwise known as forwards energy, which not only looks at and identifies seams with lowest energy, but also computes the cost in terms of energy that it costs for removing that seam or inserting upon. Backwards energy is best described in this equation above. To the right is the output of my energy function. So the way I compute energy is by using the Sobel filter. Afterwards, you use the second equation to compute the cumulative energy matrix, which essentially you look at the bottom left, direct bottom, and bottom right matrix, and you add a. The forwards energy algorithm is very similar to the backwards energy, but you also have to keep in mind the neighbors as well, and this could be seen with the CL, CU, and CR. Here are the best results that I was able to obtain in my project. The first one to the left is picture of the waterfall, and the one from the paper is seen on the right. I got a mean squared error of 4,041 and a structural similarity of 0.58. The best one I was able to obtain was for the bench, where I was able to get a mean squared error of 2,418 and a structural similarity of 0.71. The challenges I had in this project were this seam insertion and remembering the order of the seam indexes. The reason why is because the paper explains how you have to insert seams in the order of removal. The second big challenge I had was with edge cases, what you would do in the first column and the last column. And the last one was the energy function. I had to explore with different energies and different values of obtaining the matrix. To show my project real quick. So when you run my seam covering.py file, it'll create an output directory, which will have all of the images that are used in the papers. I also created a compare.py file that will plot the images side by side, as well as compute the mean squared error and structural similarity between both images. Thanks for watching.